In this video, we are going to learn about how to draw Mohr circle to find the values of principal stresses and values of normal stress and tangential stress on oblique plane. Here the statement is, at a point in the strain material subjected to stress as shown in figure, using graphical method, find normal stress, tangential stress and resultant stress across oblique plane. Also find principal stress, position of principal planes and maximum shear stress. For this example, we will see that how Mohr circle diagram will look, and then we will find the values of principal stresses and values of normal stress and tangential stress on 45-degree inclined plane. So just like graph, here I am going to draw one vertical axis and one horizontal axis, where vertical axis represent shear stress, that is tau, and horizontal axis represent the normal stress. If the normal stress is compressive in nature, then it is negative, and if the normal stress is tensile in nature, then it is positive. Here in problem, there are two mutually perpendicular normal stresses, sigma x and sigma y is given. So let me plot values of sigma x and sigma y on horizontal axis. Now there are two shear stresses corresponding to stress sigma x and sigma y, and we know the shear stress will be plotted either upwards or downwards. If the shear stress is clockwise in nature, then it is negative, and if the shear stress is anti-clockwise in nature, then it is positive. Here in problem, the shear stress corresponding to stress sigma x is trying to rotate the body in anti-clockwise direction, so it is positive, and we will plot the shear stress value upwards, and shear stress corresponding to stress sigma y is trying to rotate the body in clockwise direction, so it is negative, and I will plot this shear stress value to the downward. Now I will draw the line to join these stresses, and then taking this radius or this radius, I will draw one circle, and this radius of circle is nothing but our maximum shear stress value, which is equals to 29.157 Newton per centimeter square. Now look at 2 points. These two are the points where Mohr circle has intersect with axis of normal stress, and it is nothing but values of principal stresses. So this distance is sigma n1, that is major principal stress, which is equals to 79.154 Newton per centimeter square. And at this point, where distance is sigma n2, that is minor principal stress, which is equals to 20.84 Newton per centimeter square. Now to find out normal stress and tangential stress on 45-degree inclined plane, I will draw inclined line on this plane where my angle is 2 times theta, and here theta is 45 degree. Therefore line inclined at 90 degree to this plane, and I will draw one perpendicular line which is passing through point A, and this distance is nothing but my normal stress value on 45-degree inclined plane, which is equals to 25 Newton per centimeter square. And this distance is my tangential stress on 45-degree inclined plane, which is equals to 15 Newton per centimeter square. And if I join these 2 points, then this distance is my resultant stress on 45-degree inclined plane, which is equals to 29.15 Newton per centimeter square. So in this way, we'll draw Mohr circle to find out values of principal stresses and values of normal stress and tangential stress on inclined plane.